Today I'm going to teach you 3 different ways of calculating a normalized difference index. A normalized difference index uses band math in an image to calculate a new image that highlights characteristics on the landscape. Today I'm going to be specifically using the NDVI, or normalized difference vegetation index equation, but what I'll show you today is also applicable to other normalized difference indexes like the normalized difference snow index or the normalized difference water index. So NDVI will highlight vegetation, and you calculate it using this equation, near infrared minus red over near infrared plus red. I've already in this script uploaded the Sentinel-2 image collection and created a geometry over Estes Park in Colorado. I have created a Sentinel-2 image by filtering the Sentinel-2 image collection by my geometry, by some dates, which is the summer months of 2024, and filtering it so that I only get imagery that has less than 10% clouds. I've taken the median and then I've clipped it to my geometry, and then I've added it to the map and visualized it as a true color image. So now I'm going to show you the 3 different ways of calculating NDVI. The first way is using a built-in function in Google Earth Engine. I'm going to create a variable called NDVI1, and then I'll add my sent to image that I created, and then I'm going to use a function called normalized difference. Within this function, I need a list that has 2 different items in the list, and those are the 2 band names that we need to calculate NDVI. In this case, again, we need near infrared and red. So we should look in the Sentinel-2 information to see which bands correlate to near infrared and red. So for Sentinel, band 8 is near infrared and band 4 is red. So let's put B8 and B4. And if we want as well, we can rename the image that this creates as NDVI. Otherwise, this function will create an image band that is named ND, which is fine, but NDVI is just slightly more specific. So now we can add our NDVI1 image to the map. So I'll put NDVI1, and then I'm going to create some visual parameters. And instead of just putting that here, I'm actually going to create a variable called visparams so that I can use those visparams later for our other ways of doing NDVI as well. So within here, I'm going to add a couple of items. First, I'm going to add a palette, and I'm going to just do a very simple palette with yellow, green, and dark green. You can definitely do a more complicated palette that shows way more nuance in the landscape. And there are lots of good examples of NDVI palettes online. Again, I'm just going to do this simple one for now. And then I'm going to set some min and some max. And we might need to edit these min and max later, but for now, that is okay. And we'll put it in our map layer and see how it looks. And I'll name this layer NDVI1. So let's run that and see what it looks like. Great. So again, the yellow colors will represent areas where NDVI is low, and the dark green colors will represent areas where NDVI is high. I'm going to do max NDVI as 0.8 and see how that looks. And I think that looks a little bit better. Great. So let's move on to our second way of calculating NDVI. And in this way, we are going to do the math on our bands. First, I'm going to create a variable and specifically pick out the band names that we're interested in. So for near infrared, I'm going to put my sent to image, and then I'm going to select the near infrared band, which again is band 8. I'll do the same thing for red, sent to image, select, and then I actually need to put these in a list, band 4. And now we can create a variable called NDVI2, and we can do the math on these bands. Let's remember that the equation is near infrared minus red. I'll do near infrared, subtract red, and then I'm going to also add an extra set of parentheses just to make sure the order of operations is correct. And then I'm going to divide that top of the equation with the bottom of the equation, which is near infrared, add red. And again, I can rename this as NDVI. Okay, so now let's add that to the map and make sure that it looks the same as our NDVI1 image. Make sure to edit this so that it represents the new image. And let's run that and see what happens. So we can turn these off and on and they look the same to me. So that's great. All right, so now let's calculate NDVI using a third way. And in this method, we are going to use the expression function in Google Earth Engine. And there's actually many ways of defining expressions in Google Earth Engine. I'm just going to show you one way that I think is pretty straightforward. So I'm going to create a variable called expression, and then I'm going to define my expression within a string. In this method, we are going to call out band names using this lowercase b and then parentheses, and then we put the band name inside of that. So band B8 minus band B4. And then again, I'm going to add some parentheses to make sure that our order of operations is correct. And then I'm going to divide this top half of the equation by the bottom half of the equation, make sure that we change that minus sign to a plus sign. And now we can create our variable called NDVI3, add our sent to image here, and then we use the function called expression, and within this function, we will put our expression that we just defined up here. And then again, I'm going to rename it NDVI. Awesome. And now I'm going to add that to the map, and hopefully it looks the same as the last two images that we created. You can go in here and toggle through them. And they all look the same to me. So there you have it, 3 different ways of calculating a normalized difference index. I hope this helps.